Hello, the presentation you're about to see was developed by myself, Thomas Woolley, William Binsey and Daniel Martin. We took it to China at the beginning of the year, and the idea was to take our love and enthusiasm for mathematics out to Asia. We had a really good time out there and we decided to film it for use in schools around England. Because we were taking it out to China, the props we used were intentionally small scale, things that we could take on planes and travel with without needing huge trailers. So it comes down to things like rope, string, paper, pens, anything you could pack in a suitcase without too much worry and that's not too heavy. The first problem we're going to look at is called organising the tour. All of the problems we do are set up around our tour of China, and that's of course the first thing we had to do, organise the tour. The question itself has a very long history. It goes back to the 18th century, to a town called Königsberg, where on a Sunday morning the people of the town would challenge themselves to walk around Königsberg, crossing each of their bridge once and only once. Now Königsberg had 7 bridges, and they found that they couldn't do it, but they didn't realise why. It took a mathematician named Leonhard Euler to realise it didn't matter what the shape of the land was like or how long the bridge was. It only mattered how each of the land was connected. And that's where this lesson leads on from. Although it seems like a very small part, the subject of graph theory, and to more extent topology, is the study of what the properties of a shape and the properties of a surface beyond what it looks like. And this can be extended into other areas. There's a problem that's very similar to this called the travelling salesperson problem. It sounds very similar in that you want to visit all cities, but in the shortest distance. And although it sounds very similar to the problem we're going to look at, it's actually much harder. So hard, in fact, that if you solve it, you can win yourself $1 million. So have a go and solve the travelling salesperson problem, and if you do, you can give us 10%. Hello and welcome. My name is Thomas Woolley, and we're here today to give you a few maths games and logic puzzles taken from our presentation, A Mathematician's Holiday. The reason we produced this presentation was recently myself, Will and Dan, here we all are, we went to China. And the idea is that we would go over there and take with us our enthusiasm and our joy of mathematics and hopefully teach the Chinese students how maths can be used in everyday life. The other thing is, getting to China, and whilst we were there, we had a lot of problems, didn't we?
You will not believe.
Yeah, so what we found is that all those problems, though, could be overcome using mathematics. And these are all the problems we had to face in this presentation, and that's what you're going to be doing today. Hopefully you'll be doing it just as well as we did. So the first problem we had was we had to organise the tour, of course. We couldn't just go out into China and try and teach everyone mathematics. They didn't like that. We tried. They didn't understand us. So here are all the places we had to visit. We started in Oxford, of course. Go to London to get our flight, Beijing, Suzhou, Shanghai, Zhuhai and Seoul. They're all the places we had to visit. But the thing is, we're big tourists.
We're big tourists.
We love seeing new things. So here are all the different places we want to visit. Oxford, London, Beijing, etc. And then all the black lines represent different modes of transportation between these cities. And being big tourists, we don't want to travel on the same way twice, because we want to see something new. So for example, we could go from Oxford to London by train, and then on the way back we could go from London to Oxford by bus, seeing new things, having new experiences, and that's what we want. So this was our problem. Could we go around China and England seeing everything, seeing all these different modes of transports once and only once? And that's your problem. Okay? Do you all understand? Okay, excellent. Have a go. So as we say, we couldn't solve this problem. We couldn't do it. Why is that? Well, as you suggested, Shanghai, Zhuhai and Seoul have odd edges coming out of it. And why is that important? Well, ignore the fact that there's a beginning and the end, okay? Assume that you're somewhere in between, in the middle of your tour. Then whenever you walk into a city, you haven't finished, so you've got to exit the city. Whenever you go into a city, you have to leave the city. So if you go in twice, you have to leave twice. If you go into a city 3 times, you leave 3 times. So how many edges does a node have to have?
Even number.
An even number. So whenever we walk into a city, we leave the city. Except for the beginning and the end. The beginning we only need to leave once, and the end we only need to enter once. So if all of these cities have an even number of edges, these black lines, they're the edges, except for 2, so it could be Oxford or London, but they've got even. So if 2 edges, 2 cities have odd numbers of black lines, then one has to be the beginning, one has to be the end. Here we have 3.
Actually 4.
4. Where's the 4th? Oh, there's even Beijing. There's Beijing with for London. London's got 5. There you go. London has 5. Zhuhai has 5. Shanghai 7. Seoul 3. So there's 4 points here, all trying to be the beginning and all trying to be the end. But you can only have one beginning and one end, so you can have at most 2 points with odd numbers. So we realised we couldn't do this journey. However, we removed some of the transport links, and now could we do it? And the question is, where can we start from?
Anywhere.
Sorry?
Anywhere.
Anywhere. We can start from anywhere because all the points have an even number of edges.
And
4, 2, 4, 4, 2.
and it's connected graph.
And it's a connected graph. Yes.
He's got you there.
We're not going to Cuba. Cuba is not on our graph, so all these points are the cities we're travelling to. So yeah, we can go to Oxford, London, Beijing, Seoul, Zhuhai, Shanghai, Suzhou, back to Shanghai, Beijing, London, Oxford. Seeing new things, different each time.